So now in this video, we're going to cover the basics of electronics. So this is a diagram I made a long time ago, but has a few different drawings that I drew. So this is a pictorial that, you'll see once in a while, but not very common to see a pictorial. We have a drawing of a battery there, and then an LED. The battery is going to light up the LED. You can't do that directly. The battery will fry the LED. We have a resistor to set the amount of current that's going to flow. The LED is going to drop a couple volts because it's a red LED. Blue or green will drop about 3 volts. But in any case, the rest of the voltage goes across the resistor, and based on its resistance, it will set the current. You can calculate that with Ohm's law. You do the math in amps, and then you convert it to milliamps. Now, the multimeter that I drew here, it has to let that current flow through the meter. You have to make sure there's a gap in the circuit, and then you complete it through the meter right there. And, it's going to be about 15 milliamps in that range, as you can see right there, after you do the math, if you choose to measure it. But in any case, we got a pictorial. Usually you'll see circuits in schematic form right there. Usually they won't show the current that's flowing through, but that's all this is telling you. This is about 10 milliamps of current that's flowing through the circuit right there. You can open up the circuit at this point and bridge the gap and then measure it like you did here if you want to. You could also open up the circuit there. You could open up the circuit there and measure the current. Doesn't matter where you open it up. In a series, when there's just one path for current to flow, it's going to be the same throughout the whole thing. And I'm going positive and negative here. That's how we look at circuits. Positive to negative. That's just originally what they thought was going on, and that's how things are written. But in reality, you got electrons going from negative to positive. So, it's the same thing. Negative to positive. There's a certain amount of electrons moving, and that's indicated by the amps right there. So you do the math in amps, but then you convert it to milliamps. A milliamp is 1/1000th of an amp. So you can see this is 0.01, and then it would be 0 over there. You take the decimal point, you move it over 2 spots, and then you have milliamps. So we have 5 volts over here. This is another way you can make schematic. So this doesn't quite show the loop. It shows a starting point and an ending point. Sometimes there's an upper point working down to the lower point, and it doesn't really matter how you do it. You could also start with positive down below, work your way up, positive here, work your way to the left, whatever is most convenient for the drawing. Usually what's most convenient is starting from the left to the right, or from top to bottom, or both. That's usually most convenient. But in case, here you can see we got a lower voltage, so we need less resistance to keep the current down. LEDs in general, these indicator LEDs, they have a limit of about 20 milliamps of current. And so 10 milliamps of current is probably fine. These red ones, you might want a little bit brighter, get it closer to 15 milliamps of current. But when you get to about 20 milliamps of current, it starts wearing down how long they're going to last. And higher current's going to, shorten their life even more. So, generally try to stay, a little bit above 10 milliamps of current for these red ones. The blue and the green ones are really bright. You can be like 5 milliamps of current and, be perfectly fine. So, in any case, we have the pictorial drawing, the schematic drawing, and so on. That's how you will look at them. I added extra info. I put the current that you can expect right there. Approximations are perfectly fine. Doesn't have to be spot on. And I did the math here. Most schematic symbols, or most schematics will not do that for you. That's something you got to do. And then, again, when it comes to like 220 ohm resistors, 1000 ohm resistors, they are, especially 1000 ohm resistor, for each volt across it, you're going to get 1 milliamp of current. So we got 12 volts from the battery. Red LED is dropping a couple volts, leaving 10 volts across the 1000 ohm resistor. As you can see there, makes the math easy. 10 milliamps of current. Pretty straightforward with the 1000 ohms. So, practice these simple ones first. When it comes to the math, this one, you can just do mental math. Really easy. Each volt across it is 1 milliamp of current. So you just set whatever voltage across it you want. Normally, though, you're working with a fixed voltage, and then, you're going to be dropping some voltage, and so that gives you the amount of voltage across the resistor. Now, LEDs, you got to put them in a certain way. So I got a blue LED right here. We got a longer lead there, shorter lead there. I did not clip it. And then this side, the shorter lead, the cathode, usually has a shaved end. That's what it's called, cathode. The longer side right there is the anode. Now, of course, if you cut them, then they could be whatever size. So that's only if you haven't trimmed them. And maybe you'll even find LEDs where they're both the same length. And maybe some will have the cathode with the longer lead, the anode with the shorter lead. I have never seen that, but you know, there's probably those out there somewhere for some reason. But any case, this is generally what you'll find. Anode, longer lead, cathode, shorter lead. So now, once you understand the basics of a circuit from the schematics, maybe a pictorial, and then reading about it, or in this case, me explaining them, you want to actually build those circuits. So generally, you'll do that on a breadboard that we have right there. This is a cheap one, but cheap ones are plenty fine. And then a power supply. So this will, you know, simulate, in this case, a USB output. They're about 5.1 volts. If you're going to power something with that, you can, you know, plug into a USB. There's alligator clips that come out, and you could power the breadboard if you have USB power sources laying around. We can limit the maximum current. That's a really nice thing about using a power supply. So usually you got a bench power supply. It lays on a bench, but then the screen would be like facing me. So, you know, can't really record it. That's why I bought this one right here. Costs more money, but it's nice for my videos. So be aware of that. But any case, we're going to start with the 5 volt, 220 ohm resistor protecting a red LED circuit. We're going to get somewhere around 14 milliamps of current. So I already have the red LED on the board. We put the long lead in the anode. We're going to put it up higher, short lead the cathode down lower. Remember, we got to get the anode more positive than the cathode. In fact, I'm going to move it over there. And 220 ohm resistor right there. We got red, black, for 220 ohms, and then brown for 1% tolerance. You don't need to memorize the value of the resistors. I did for these ones because I lost the bag that they came in. But usually the bag will have them labeled. This is 470 ohms, and you can just compare the color code with the resistor right there. So be aware of that. You don't have to memorize the color code, but you do have to be aware of it, and you know, it'll come quickly. So yeah, we got them in series, and this breadboard header right there, plugged into the blue row, is connected to all these holes right there, whatever I plug onto that. Same with the red one right there, and then I got jumpers to transfer them over to the other rail. That's what that's called, a power rail. But I'm just going to pluck a couple of these jumpers right there and just put them on both sides of the circuit, so we can just plug directly across the circuit. So there's all kinds of ways you can wire things up. And the pins are not showing very much. They kind of got sucked out. And so what I'm going to do is push them on here. So that's how you can lengthen one side. So one side's supposed to be longer and the other side is shorter. And there we go. So now we have that connection that I can make with the alligator clips. So you can see there's a little bit more work than what I already had set up. It's better to just keep what you got set up there. But just showing different ways to make these connections. So power is off right now, so the LEDs are not going to light up. But once I connect the alligator clips and turn the power on, the power supply, so it's on now, and we are not lit up for some reason. So that is not good. This is a cheap board, kind of has bad connection. So we're going to have to do a little troubleshooting right there. We got 10 or 5 volts there. It's showing how much current would be flowing, and I'm off a spot with the plug right there. That's the problem. So that's easy to do with these breadboards. Insert something into the wrong slot, and there we go. We got a red LED lit up. This is not as accurate as a multimeter, but you know, it's going to be close to this, and this may even be more accurate than our calculations. Calculations are not perfect because real world components aren't perfect either when it comes to math right there. But there you can see red LED is lit up. As I said before, blue LEDs are naturally brighter. When I insert the blue LED, it's actually going to have less current going through it because it drops a little bit more voltage, 3 volts instead of 2, but it's quite a bit brighter. So, and person you can really tell that's brighter. It's a little harder to tell on camera. So now, earlier I showed multimeters, and when you learn electronics, you really want to learn how to use a multimeter. So what multimeter means is we can measure a number of different things. Mostly we're interested in voltage, sometimes resistance, and current. But voltage is the main measurement that you take. So we're going to quickly do this. This is auto ranging. We're working with 5 volts. If there's numbers alongside the V for voltage, then you would set it to a number higher than what you're going to measure. And right now we are going to measure DC. If we want to measure AC, we would press that. But the vast majority of basic electronics is DC, and so that's just what you can expect to use right there. Pretty straightforward. So I got the probes here, and that's the other end of this. I don't have to move the red probe here for anything other than high current. So the probes generally always stay in the same spot here. Again, I only have to move the red probe for high current, which, you know, for basic electronics, you don't even ever have to do. So there we go. We can measure the voltage right there, and it looks like we're losing a little bit of voltage along the way. It's not showing a full 5.10 volts. And when it comes to the circuit, so right now our header pins are kind of awkward. I can clip them, you know, from an angle right there. That's fine as long as I get one of these header pins pretty good right there, then we will have a good enough connection for this. So we're powering the circuit right now. So yeah, we can measure again the alligator clips where they clip into the probes or come down here anywhere. That's called a node right there. This is a node. It's all one connection. This side of the resistor, the header pins, and the alligator clip is a node. Same as up there. So we, you know, I already measured the jumpers across there. Losing a little bit of voltage because this is a cheap breadboard, and connections are not as great as a better one, but still doing okay. So blue LED, as I said before, drops about 3 volts right there, leaving about 2 volts across the resistor. So that's a fair amount of voltage lower than we had with the red LED. So we got about 10 milliamps of current flowing. There's less voltage across the resistor, so less current. We can just pluck the blue LED, grab the red LED, and put it in the place. So again, we got to put the longer lead, the anode, towards more positive, shorter lead, the cathode, going to the resistor, and now we have a complete circuit. So I'll zoom in a little bit. Again, we can measure the total voltage either at the alligator clips or across the components right there. Basically same thing. Red LED is dropping about 2 volts, which gives us about 3 volts across the 220 ohm resistor right there. So we're going to get about 50% more current right now flowing through the circuit than we had before. So now, when it comes to measuring current, we have to be more careful. So we have the multimeter set to measure voltage. It's good to keep it doing that. We need to open up the circuit. These resistors do get hot, so you know it's not hot right now, but just be aware of that. So best to turn the power off, let the resistor cool down before you handle it. So we have the meter set to voltage. We opened up the circuit, so there's a gap right now, and we are going to take the meter. And again, I don't have to move the probe for anything other than high current. That wire is going to be kind of annoying. But we're going to measure in milliamps right there. So this one's really important. If it has numbers next to the amps right there, milliamps, whatever, make sure you set it to a number higher than you can expect to measure. If you put more current through the meter than what it's set to measure, there's fuses in there, and you'll blow the fuse. In fact, I'm pretty sure I blew the 10 amp fuse. I cannot measure you know, like 1 to 10 amps right now. In fact, I think anything above 0.6 amps, 600 milliamps of current, you want to set it to the amp range for this meter. But in any case, there we go. We have the gap and the meter set to measure milliamps, and all I have to do is come down to the cathode right there, and then up to over to the resistor right there with the black probe. And there you can see we got about 13 milliamps of current. And now, it might change a little bit as things warm up. Electronics tends to conduct a little bit better when things warm up. So, we're only getting 20 milliamps right here, because I set a limit on the power supply, but we're just measuring the current through the resistor right there. So that was the limit we set at the power supply. Let's talk about that really quick. That's one nice thing about power supplies versus batteries, is you can set a limit on the current, and then you don't have to worry about overpowering something. There we go. I want to change this. Now it's showing the voltage, and what I'm going to do is I'm going to try to just measure the current through the resistor alone right there. And you can see the power supply lowered a voltage. So it did that to limit the current. So 5 volts would have put more than 20 milliamps of current. I lost my connection through the resistor. So it had to lower the voltage in order to set 20 milliamps of current. That's why we got that protection. Now, if we want to see the actual current flowing through the resistor, I can set that up to about 30 milliamps of current, which if we put through the LED for a brief period of time, probably would not damage it, as long as we kept it really brief. But there you can see. Now we got about 22.86 milliamps of current. So that's one way I do troubleshooting, is if I, get the maximum current right there on the power supply. I know that I either short-circuited something or something like that that's causing more current than I want. You can see next to the 20 milliamps up there, 0.02 amps, there's a little CC popping up right there. That's telling me it's constant current. Now the power supply is setting a current, not a voltage. And generally, unless you're purposely using the power supply to set a current, generally you don't want it setting a current. You just want it setting the voltage, and the load will take care of the current, like we got right there, how much current is flowing. And so that's another way to troubleshoot. So now, first thing I'm going to do before we move on is turn the multimeter off. At least get it off of measuring current right there. So we're okay setting it to measure voltage. At some point it's going to start beeping to let me know I didn't turn it off. But that's not a big deal. But we don't want to accidentally blow the fuse by wiring up the meter. So now we're going to rewire the circuit right here. I'm going to unplug these, and in fact from now on I'm not going to connect across here. So I'm going to pop this back out and put it back to the negative supply right there. So I can plug the positive alligator clip there, and it would also power this side over there, both of these rows next to the red line, and then plug the black alligator clip from the power supply there. It'll power all of these holes next to the blue line right there, as well as over there. So we will take away the 220 ohm resistor, and now we'll look at 9 volts, 470 ohms. So there's the 470 ohm resistor. Yellow and violet for 4.7 are very commonly used values, and then the whether it's 47, 470, which this is, or 4,700 and so on, is determined by the multiplier color of the bands. So be aware of that. So we're not going to go in depth on the color code, but that's how you read the value of the resistors. And these breadboard headers are plugged into this board a lot stronger than most things. They must be a little bit wider. So in any case, we're going to put the red jumper there. Make sure we have a good connection. As we saw before, I accidentally went to the wrong hole with my header thing, and therefore we had an opening in the circuit and it would not light up. So you want to be very careful that you wired everything properly, and then if you have a circuit that doesn't work, double check the wiring. So now I already jumped ahead and connected the power supply right there, because we already showed all the other steps of that. It's all basic stuff. But in any case, there you can see we got the red LED. First off, it's not showing up very good because I haven't raised the voltage yet. I actually forgot about that. I was wondering why the LED looks so dim. But I turned the lamp down. That helps the camera show the light of the LED a little bit more. So we have a 470 ohm resistor protecting it. We can bump the power supply up to 9 volts. Even 10 volts wasn't terrible. But in any case, 9 volts there, somewhere around about 13 milliamps of current flowing through the circuit. So again, right from the start, you want to get multimeter practice. So we set to V for voltage. Don't have to move the red probe or the black probe for any of this. We can measure, you know, the supply voltage at the alligator clips, and that's going to give us our highest measurement right there. Or we can measure it across the load. Again, this is a cheap board. We have a bunch of connections. I got the probes backwards. I didn't mean to do that, but that's fine. You just get a negative voltage. But in any case, this breadboard's cheap, doesn't make the best connections, and everywhere you have connections there's going to be a little bit of resistance, at least a little bit. And there you can see we're losing, you know, a fair amount of voltage once we finally get to the load. But, you know, it's close to a 9. And again, it's kind of a cheap board. These are thin leads on there. As I press on them and stuff, it's gonna, and kind of shift a little bit, it's gonna kind of affect the connection. Something to be aware of. But again, you know, got about 9 volts. Red LED still drops about 2 volts. That is, you know, pretty constant. How much voltage is going to be across the LEDs. Changes a little bit based on how much current's flowing through it, but it's generally going to be about 2 volts for the red LED and about 3 volts for a blue or a green LED. And so on. The warmer colors tend to be about 2 volts. And then you can see across the resistor, we got about 6.36. So that's where our variable is going to be when it comes to the voltage. As well, the power supply, we set a voltage. It's going to be constant across the red LED for the most part, just changes slightly. The resistor is going to be where the voltage changes a lot. That's why when you do Ohm's law, you take the supply voltage, subtract the diode drop, and then the rest of the voltage across the resistor is what will ultimately set the current through the entire circuit. The power supply, the resistor, the LED, all the wires, and so on, which also have, everything else has a little bit of resistance compared to the resistor, and so, you know, they're going to lower the current a little bit more. They're going to build up a little bit of voltage across them. We could look at that right now. So we have the resistor right here. This would be the more positive side. Again, if you put it backwards, you just get a negative number. But we can see how much resistance we're losing, or how much voltage, I mean, we're losing when it comes to this connector to the resistor right there. Just over there, we're losing about 0.01 volts right there. So not a lot of voltage, but everything is dropping like a little bit voltage. Something you got to keep in mind. Not a big deal most of the time, but something to keep in mind. So we're going to measure current. Again, the resistor, you know, it's fairly warm right there. Hasn't been on a terribly long time. You want to turn the power off before you grab it, you know, usually, but not end of the world. These resistors are small. You know, you kind of get a burning feeling, like you got kind of a major burn, but you know, it's not bad. Large resistors are big enough to actually cause a severe burn. So we had to open up the circuit to measure the current. Again, if you put the probes backwards, you just get a negative current right there. So, you know, no big deal right there. And the meters are made to measure alternating voltage and current, and they can take current going in either direction. So you don't have to worry about that. But yeah, there we go. We got, you know, like 13.6 milliamps of current flowing through there. And of course it's going to be lower with the blue LED. I didn't measure the voltage. But you know, it's still going to be about 3 volts across the blue LED, leaving about, since we got 9 volts, about 6 volts across the resistor. So there'd be less current, but blue LEDs, there you can see, they're, you know, so much brighter, even at the same current. So, you know, probably like 3 milliamps of current is plenty fine for the blue LED. Now, we don't have to move the resistor. It comes to a dead end, but when you measure the resistance, you don't want voltage across it. So we will move it there just to be extra safe. But we didn't really need to, because one end was already coming to a dead end. The power supply could not push any current. So, oh well, I just set it to the resistor. That's the omega symbol for ohms, which is the unit of resistance. And so yeah, showing even in the millions of ohms. I think this goes above, or somewhere around 200 million ohms. Million ohms, not milliohms. 200 million ohms. Having trouble saying that for some reason. So in any case, that's mega for millions. It's out of limit though. There's more than, I think, 200 million ohms of resistance between these two probes. So we just go to, doesn't matter which side you put the probe, just touch the wire leads right there. And auto ranging takes a little bit to get, you know, the proper setting before it displays the value. So it looks like it's thinking for a little bit. But in any case, there you can see out of that 470 ohms, look like we're a little bit shy of that. So that's what that 1% tolerance, the brown band on here, indicates. You can expect this resistor to be, maybe 1% lower than 470, maybe 1% higher. And I can't do the mental math right now. I'm not sure if this falls within 1% or not. I think it does. But in any case, these are cheap resistors. They, I think might get down to like 2% off. But still, they're very close to their rated value. With the cheap resistors, you don't get as high a quality, but you don't need terribly high quality with resistors. So, in any case, safe to leave this to measuring resistance. Voltage is safer, but when you're done with the meter, you should really just turn it off. And finally, the 1000 ohm resistor, which will usually be indicated by 1K. So we got the 470 on there, the blue LED. First, let's put the red LED. And so this is at 9 volts right here with the 470 ohm resistor. I did not change that yet. And I will grab the 1000 ohm resistor. And the resistor, again, came out of this baggie. That's how I know it's 1K. You can see 1K there. And I also wrote it up on there in marker. So with these baggies, it's really easy to just use permanent marker on them to write their values. When it starts fading, you just write it again. Oh, sorry, that was blurry. And we'll pull back. So now we got the 9 volts there. Since it's a 1000 ohm resistor, with the blue LED, this would be plenty amount of current, even at the lower current. It was plenty bright, as we saw before. But I will raise this up to 12 volts right there. We got about 10 milliamps of current, approximately flowing through there. And a blue LED is going to be a little bit lower, but again, it's going to look quite a bit brighter. In person, it's really hard to look at the blue LED. It's so bright. Whereas the red LED, it's, not that hard. I really shouldn't stare at it directly, making my eyes a little bit sore. Looking directly at it from this distance, but nowhere near as bad as the blue LED. So yeah, we got the meter. Again, measure voltage. We'll just do this quick. We covered before. One thing to keep in mind, we got the supply voltage probably going to be a little bit lower than what the power supply said. Yep, power supply is 12.1, and then this is 12.04 right there. Probably because we lost a little bit due to the resistance where we have connections between what the power supply is setting, and as you can see over there, the breadboard jumpers and everything. As you get farther from the power supply, closer to the circuit, you're going to have a little bit less voltage. Now, really good connections will get rid of almost all that voltage drop. You'll get almost completely all of the voltage across the load, but here we're falling short. Again, we're working with 12 volts, but the LED still drops 2 volts, no matter what. So we got 10 volts across the 1000 ohm resistor, which gives us about 10 milliamps of current. There you can see 12 volts, and it's showing a little bit less. So, these are not perfect numbers. If that's like 9.9 milliamps of current, it will still say 9 milliamps of current, the way that power supply is. It doesn't like round up. So yeah, we open up the circuit. Again, we can measure the current. It's in milliamps. I don't have to move the red probe for anything but high current, and pretty straightforward. We can do this test. We could also measure the blue one. I got the probes backwards, but no big deal right there. So I don't make this many mistakes when I'm not recording. I'm making more while I'm recording, but that's fine. These are all common mistakes. There we go. We got about 10 milliamps of current, and of course the blue LED is going to be a little bit lower. Might as well show that, because it drops another volt, as we saw before. So didn't measure that, but there we go. We got about 8.9 milliamps current, approximately. So as you get higher voltage, the voltage drop of the blue LED compared to the red LED is not going to make as big of a difference, because you got more voltage to work with. Now, I definitely don't want to measure current by accident. I'm not going to even accidentally do that. And I got the power supply limited to 20 milliamps of current, so we're not going to damage the meter. But that's something you never want to do. Accidentally put too much current through a meter. So yeah, there we got about 3 volts across the blue LED, and leaving about 6 volts, or 9 volts I mean. That's right, we bumped it up to 12. So 12 subtract 3 is 9. Basic math right there. So we'll put that over there. And I do have one side of the resistor connected to the negative supply. We can still measure resistance right there. That's why I opened it up, just to get more practice measuring resistance. So when you're first learning electronics, it's good to take all of these measurements right there. Get used to that. So that's in kilo ohms. So it's kilo up there, thousands of ohms. Probably a little bit shy of 1,000. But again, there's a 1% tolerance. And these cheap resistors, maybe even close to like 2%, since they're cheap. You know, you take that. And, you know, the difference between 1% off and 2% off is no big deal at all when it comes to most circuits. So, in any case, this video was a lot longer than I expected, but hopefully you still enjoyed it. So, we'll see, you know, how well it does and how long people watch. But in any case, hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help a lot. I'll see you in the next video.